if we need to, we need to split this one up.
Yes.
Not one?
Not really.
Oh, yeah, those two functions?
There are two different functions, so we would have to split them up and then add them together. But if some of you also thought about splitting up with the above and the below, total area, also think of area between, because as we talked about last year when we were talking about top and bottom, right and left, building up to discs and washers. Area between was always positive as well. But this also gets applied to total distance traveled, which remember as well. So total area. Similar way of saying it, area between, similar to, bless you, total distance traveled. So as we get down to number 42, if they want the total area between -2 to 2 of 3x squared minus 3, what are we going to do? You better visualize.
-3, you bring it down 3. It's not, it's skinnier.
And it's wide.
What's going on at -2 and 2? Where is it? Are those intercepts, or are they before? Are they after?
They're just bound here.
They are the bounds, so we need to think about, do we have some area above and some area below?
Yes.
Yeah, 1.
Because my intercepts would be at 1 and -1. So then I'm gonna have to deal with area above. Now the nice thing is it symmetric? Is it still, is it still even? Does it still have y-axis symmetry? The answer is yes. So really I don't have to worry about from 0 to 2, technically, or from -2 to 0. But guys, if they say the total area between, am I thinking about the negative as negative and the positive as positive? No. I need to think absolute value. So how would we take the integral from 0 to 2 and then double it, because it's symmetric, of the absolute value of 3x squared minus 3? We'll have to split it up, but split it up where?
0, 1.
0, 1, 1,
At
2.
1. Good. So we have to have our 2 be on the outside. We have to go from 0 to 1. Well, we can integrate this, right? So that'd be x cubed minus 3x. Double check me.
Oh, yeah.
From 0 to 1. Does that make sense?
Yes, it does.
Because remember how we do absolute value is we split it up at any zeros, especially if we know the sign has to change. If we don't visualize the picture, we just split up at the zeros and then we take the absolute value of the entire integration. Corey's already done. 1 minus 3 is -2, minus 0 is -2, but absolute value?
2.
Positive 2. That's the integral from 0 to 1. Then we have 8 minus 6 is 2 again. 2 minus -2?
0.
No. Double check. 8 minus 6 would be 2. Plugging in 1, that'd be 1 minus 3, which would be plus 2. Right? So that'd be 4 and 2 is 6, and 6 and 2 is 12. Okay, so be careful. Some of the wording, some of the directions you might not totally be ready for. But it's saying total area between. When it says area between, we're not worrying about the positives, the negatives. We're thinking about absolute value. Katrina, you good?
Yeah.
Okay. What's different about number 46? And you guys basically said it, so what are we going to do?
Yeah, have 2 different angles.
Yeah. So there are 2 different integrals. You're going to have your integral from 0 to 1. But do I have to worry about absolute value? Anything? No, nothing's below. Nothing's below. So therefore I can go from 0 to 1? Yeah. We have 1 to 2. Anti-derive x to the 1/2, just quickly.
3 halves, x, well, whatever. Yes, that's it.
1/3 x cubed. Thank you, that's right.
2/3.
1 and 2/3.
Just 2/3, because 1 to any power and 0 to nothing. Just 2/3.
2/3 plus 8/3 minus
8/3 minus 1. 7 is 7.
Hinge 2 plus 8 is 10, and 10 minus 1 is 9, and 9 over 3 is?
3.
That's not too shabby. Yeah, Carolyn.
So for the first one, you split up the integral because from the function was below.
And it said total area between, so we're not solving the integral, and we're not solving the accumulation of the area, we're trying to figure out what's the total area of this figure. And so that's why we had to think of absolute value. So we had to make the negative positive, but to do that, we had to split up and consider, because as soon as you go a little bit past that bound, it's gonna see this is negative and that is positive, and like cancel out, and we can't have that. Yeah, so we split up at the 0 or the intercepts. All right, so kiddos, area between, total area between. Total distance traveled, just think absolute value if you need it, right?
Yes, ma'am.
Okay. So then, solve. You don't have a picture. I guess you can visualize a picture if you really want. But you don't even need to visualize a picture. How would we solve? I'm just checking on you.
Isn't that just absolute value of x just to the right thing?
That's one way.
Oh, right.
So Noah's saying that you could just make it the integral of the absolute value of x from -3 to 1.
That's just fine.
Why would you do that?
And you could draw it and then make triangles and find your areas, but nah.
Just
If you want to draw it, once again, you
Negative 1 to
can.
0.
But how can we do it without?
You can do negative 1 to 0.
No, don't do -1 to 0.
And then you can do triangles.
Kyle, what would you do?
Take this 1 to 6.
Why can't you just keep it down?
Why did I split up?
Because it's a water.
Oh, because it's
You don't even have to get the graph, but if you want to get the graph to show, it is going to be 2 down, which means it's going to hit up 1 over 1. Where is the possible sign change? You always take the 0. Now, could you do 1/2 base times height? Yeah. Could you do triangles? Yeah.
2.
But could you also just split it up and then just integrate x minus 2 like normal? Remember how we do it without pictures? Because you guys know some of the pictures get nasty. Right? I'm just solving just because. Don't do anything with the absolute value until you finish solving each of the integrals separately. The absolute value is for the very end before you add. The square is 4, 4 over 2 is 2. I am not changing any of the minuses to pluses. I am solving, I'm evaluating the integral and saving the absolute value till the end. So it should be, double check my math though. 4 over 2 is 2, minus 2 times 2 is 4, minus. Plugging in the -1, 1/2, -1 is plus 2. Good. Plugging in the -1, but you're subtracting f of a.
Oh, wait, 2 minus 1.
Plugging in 3 squared is 9/2. Minus 6, minus 4 over 2 is 2, minus 2 times 2 is 4. Twos cancel, right?
Yep.
-4 minus 1/2 would be a -9/2.
Yes.
2 minus 4 is -2, -6 minus -2 plus 2 is -4. 9/2 minus 8/2 is, double check. -2, -6 minus -2 plus 2, -4. 9/2 minus 8/2. Yeah, right? And we end up with 5.
Yeah.
You guys agree?
Yeah.
Yeah, maybe. But remember, I am preparing you for functions where the graphs wouldn't even necessarily be possible.
On the left side, keep going.
Oh, I was graphing the line. I wasn't graphing the absolute value. This would be the absolute value.
That's what I was though. And something like
1/2 base 10 site. Yeah, that works. But once again, I am preparing you guys for the ones where the graphs would not have been as straightforward or even geometric. This one, yes, the graph would have been two triangles added together. Questions on solving? We got it? Split up at the zeros?
Yes, ma'am.
Ooh! How do you think about the antiderivative graphically? The derivative, we think about tangent lines. The second derivative, we think about concavity. The antiderivative, we think Kyle.
Like the lines.
On a graph. If we think about the first derivative, slopes of tangents, if we have f. If we think about the second derivative, it's the concavity of f.
Yeah.
If we think about the antiderivative, we think about areas and the accumulation of areas from an initial. From an initial. So if you're given a function defined as an integral, what if you're given a function defined as an integral, aka what if you're given an antiderivative, but you're given a graph of the integrand, aka a graph of your original. To think about h, we have to think about his antiderivative. Looking at a graph of f, how do we graphically consider h? With the accumulator. You guys ready for me to zoom in? Oh, struggle. Make them a little bit smaller.
What's up?
Was this a homework problem?
Yes. 58.
Oh, 58 was?
58, 59.
All right, cool kids. This is very AP-ish, right?
Yeah.
Gotta think through carefully. We're given a graph of an original. We're trying to think about his antiderivative as signified by h being defined as the accumulator function of f. How do we find h of 0? Plug in the lines, right? Pause, we're gonna do this. We're gonna do this. We're gonna do that. We're gonna do this. I forgot I had a blank page for this very purpose. That's why he was so big. Okay. So letter A. How would you show your work? Good. 0 to 0 of f of t dt, and we don't need to do anything else because that just equals
0.
Easy cheesy. All right, fine. Maybe not AP-ish. Letter B.
From 0 to 6.
Pause. I don't want to hear an answer. I want to hear why.
H
Is increasing when
H is derivative.
h prime, which equals
f of x is greater than 0.
this occurs for. Okay. Now let's get an answer.
0 to 6.
The ball is open.
Because that's when the y values are above. Why is it going to be open and not closed? At 6?
Because at 6 is 0.
There's a 0.
But why is it going to be closed at 0?
Because that's when it
Because
starts.
Not where it starts. It's positive at 0.
Switch.
So it's positive at 0. We leave open at the zeros because it's not increasing at a 0. It's momentarily constant, but we don't really say constant unless it's over an interval. The 0 is not increasing, but everywhere in between, including at 0, because it is a positive y value even at 0. Done. Dun, 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 dun.
Why is it positive? I don't get it.
Because f of 0 is 8, which is greater than 0. So it's increasing at 0. H is increasing at 0. The antiderivative. So remember, h is increasing when h prime, now some people did this really fast, remember h prime, take the derivative of the integral, which is f of x, right? H prime is equal to the derivative of the integral, which is f of x. So when f of x is greater than 0, which where are f's y's? Above, at 0, all the way up to, but not including 6.
Oh, when I say when f is positive, or when f is increasing, f is positive?
When f is positive, h prime is positive, which means h is increasing.
Okay. Nope. H is the word. F of x is the derivative.
What's the derivative
Easier. I see another.
So according to our forever card, h is increasing when his derivative is positive. His derivative is just f, not. His derivative is indicated by the y values of f.
So the derivative function of f is the graph of f.
I'll just overthinking it.
Maybe I'm
The derivative function of f is seen by the tangent lines of this graph, which would be the second derivative. And the second derivative of h would be what you're referring to, which is f prime, which would be when f is increasing or decreasing, we know f prime is positive or negative, which we know h double prime. Letter C. Let's keep developing because actually I already started solving letter C, didn't I?
Yes.
Because concave up, well, what are we going to say?
The thing is
The
increasing.
slopes
When h
Is-
prime,
sorry.
when h double prime is greater than.
H is concave up.
Why not
f
we
of
just
x
You can put it two ways. When h double prime
change it? That's
sorry, x, not t, is positive. Wait, pause. Some people tend to mix up some of these wordings and it does totally mess up their answer. H double prime, what needs to be true for h to be concave up? Positive. And h double prime is taking the derivative of the derivative, which would be f prime. So I could say equals f prime is positive. But some of you are saying the other way of putting it, which would be when h prime is increasing. You cannot switch increasing and positive. They are not synonyms. One is talking about the movement that's occurring as indicated by the sign of the derivative. So, when f prime is positive, h double prime is positive. When f is increasing, h prime is increasing. These both symbolize when h is concave up. And when is that going to be occurring?
around there,
Yeah.
9, 12, yeah.
Now, obviously this isn't an exact AP question or else they would have marked those points. They didn't mark the points and I apologize for that. But yeah, we'll go ahead and say
9, 12, 9.5.
9.5.
9.5.
You get that?
I'll put this point as 9, negative 2. The AP would have labeled that, they would have shown it to you as the relative interval. So you would have been able to use it. This occurs, no.
Is it
At 9, the derivative value of, I should say the second derivative of h, or the derivative of f is 0. So we have to keep it open at 9, since the derivative is 0. However, what is the derivative at 12?
0?
F prime is 0, meaning h double prime is 0, so it's not concave up or concave down there. It's neither. But what's the slope at 12? So since it's positive, since f prime is positive, since f is increasing at 12, we would go ahead and close 12. Because we're talking about the slopes of f. Any of the zeros we have to keep open, so the slope was 0 at 9. So we can't include that with the increasing or include that with the positive, but is the slope positive at 12? The answer is yes, so we do include that.
Can you explain the first part of C, when H is C, when H double prime connects?
Well, concave up, we know that according to our forever card, is when the second derivative is positive or when the first derivative is increasing. These technically mean the same thing. Second derivative positive means the antiderivative was increasing. But we had to look at our graph and say, well, who is the second derivative? Well, first of all, we have to start with who is H, the accumulator, who is H prime, the integrand. If it was a U, it would be f of u times u prime, but either way, the integrand. And then who is H double prime? Well, take a derivative of this guy.
Yeah. So it's, by positive, you mean above the x-axis?
No. I have a graph of f.
Yeah.
This indicates the slopes of f. So when are the slopes of f positive? And it's sloped up for only this portion.
Okay.
Does that make sense?
Yeah, that makes sense.
Or an easier way of putting it is when f is increasing. That helps your brain a little bit.
Yeah.
Letter D. Ooh. They're asking for h of 12? I like the increasing, decreasing better because we have, we need to think about the antiderivative.
Because the absolute value
But-
of the interaction.
Why is it absolute value?
Well, because you're comparing the bottom area, no, the top area to the bottom one.
Oh, when you put in 12, you can subtract.
Well, it goes from
0 to 6.
We know that h of 0 is 0, so we know an initial starting point, right? So h of 0 is 0, we know an initial starting point. And then h of 12, what has happened or what has occurred? How can we think of antiderivatives? You guys told me area, right? But as you go from 0 to 12, they're asking, is this positive or negative? Isn't that this area right here?
I would say it's
So
positive.
then, what Kyle is trying to say is, if we compare this area with that area, this one is a positive, take it as a positive, this one needs to be subtracted. Which one seems to be greater? Okay, so we could say the absolute value of the integral from 0 to 6 of f of x dx is greater than the absolute value, the integral from 6 to 12 of f of x dx. Isn't that what you're saying?
Do you compare in terms of C or X?
I wasn't looking at the function, sorry, I was just thinking. Yeah, properly you should do f of t to t.
Can you just say
We put it this way.
like therefore since that it
Can't I just use like a little integration not property, but even just solving notation to say, well, if I'm subtracting these two when I go to find this integral, and h of 12 equals h of 0 plus, and h of 0 is just 0. I could do 0 plus. This is going to have to be, since that is smaller than that, this is going to have to be greater than 0.
How do you have to make the absolute value? Can you just say
Yeah, you
integral
can
from
just plus.
0 to 6 plus
Yeah,
6 4? Can you just say that?
and you can just find the negative positive value.
like re-identification, you say that.
It doesn't fit for all.
Well, I know you can say that, because I know it's true, but I don't know if your absolute value statement has any bearing, because you couldn't plug it in. Because if it didn't have absolute value, you're using absolute value in one expression, but not in the other, so what was the point of the initial? You should have used words instead to say that the area from 0 to 6 that's positive is greater than the area from 6 to 12, which is negative.
So if you use absolute values in one point.
You should use it,
Oh, okay.
because otherwise there's no substitution that can occur.
And also, can you just say redemption since during absolute value integral from 0 to 6 is greater than that absolute value integral from 6 to 12? Can you just say that h of 12 is greater than is positive? You do that?
No, you just talk about how h of 12 is h of 2 plus the area.
So you have to
H of
relate-
0
you have
plus
to-
the
You
area.
have to relate the two.
The integration is net change. To get to a final, you have to talk about the initial plus the change. But you can't just use words to explain that the positive area or the positive displacement or the positive change of h from 0 to 6 is greater than the negative change from 6 to 12. You can just use words. You don't have to use the expression. I was just using what you said. Where are we at? Letter E?
Yes.
Where does h achieve its maximum value?
Positive to negative, so 6.
6.
Yeah, it's in f of 6.
We don't start with an answer.
Oh.
Okay,
It says f of
H
6.
prime is greater
As
than
f of 6, f of 6 equals to 0, therefore it's a critical number,
Since h of 6 is equal to,
but h prime is 6, right?
oh, I knew that. Since h prime, so to establish it's a critical number, that's what a lot of you guys forgot last year, many, many, many times. First establish it's a critical number, and
It changes from positive
h prime of x, which equals f of x, changes
from positive to negative at x equals 6. Then h of 6 must have a maximum value at x equals 6. Not h 6.
Well, is that how you say that?
there exists.
There you go. What the?
Therefore is 3 dots in the triangle.
No, she told us to read them.
Wait, what's that thingy?
It's a backwards e, means there exists.
Oh, that's
I only use that.
Wait, can you draw it? Oh.
Backwards e. This is for all. This is therefore. This is there exists. ST is such that, that one's
And then
wrong.
all reals is like the
Yeah.
double R.
There's all integers. That's nasty though. Whole numbers are just a W. Natural numbers are just an N.
I know if no is just capital I.
What was the V with the one?
V?
Yeah, the V with the
Oh,
one.
that was.
Oh, sorry.
That was all.
Oh, for all.
Oh.
Oh man, we have one more. Struggle, where's the min?
Doesn't take.
Wait a minute, pause. Did we actually answer letter E?
Where is
Where?
No, because you have to plug it in, you're finding out.
We said it was a relative max. What's it asking for?
What's the back?
Absolute.
Max value. Max
There
value.
exists.
Absolute max. Struggle. Well, we did show it's a relative. That's good and all.
Can you even solve it?
Would you
You can't find the
area
endpoint,
exactly though.
can't you?
What'd you say?
You can't find the area exactly though.
We can't find the actual endpoints, like what they actually equal. That's a good idea to test the endpoints. We do know h of 0 is 0. How do we know that h of 6 has to be higher than h of 0?
Oh, because
Because
h
it's
max.
Because h is increasing. Oh, so let's just state that. Isn't it strictly increasing, strictly decreasing?
Oh, yeah.
So it isn't absolute.
Before x equals 6.
You could just put it on this.
Oh,
probably summarize that a little bit quicker, but long story short, your function is strictly increasing before, strictly decreasing after. Of course, the absolute max must be a relative max. And what are we doing? Ruling out the endpoints. And why did I bring that up? Letter F says where is the minimum, and you guys don't have a relative min, so that wouldn't work.
You could just
Sorry, hold on, pause.
But if it says value, is that why we can't say the value? Saying the value of the y?
It says where does it achieve its value? Long story short, it doesn't say local min, it doesn't say relative min or max. It says its min, its max, so it means the min, the max.
Okay.
Does that make sense?
Yeah.
So, min.
There are none.
This,
Did we get that? It was the increasing on 0 to 6 and decreasing on 6 to 12 because it's like above and below.
Yeah.
Yeah, because
okay.
12.
And F is equal to H
Oh,
prime,
it
so
is.
F's above and below is H prime's positive.
So since
Does that make sense?
Yeah.
So since in the
Since
like I think it's called extrema, like absolute extrema, like where is that?
absolute extrema is what we're looking for.
Yeah, so you just say like since absolute extrema occurs at critical numbers and at endpoints.
Okay. I'm just trying to think of how to summarize, but yeah.
Oh,
So
since-
Kyle's saying the theorem absolute has to happen at critical numbers or endpoints.
And our points are 0, 6, and 12.
Oh, yeah.
And with the summary.
We've already
The 0 to
established that
6
12
already
is
established
greater than
that.
0.
6 can already be narrowed down because he's a relative max,
And we
right?
already established that
12 is
8
greater
to
than
12 is greater than 0,
So if
but
you do
8 to 0 is 0.
8 to 12 is greater than 0.
Yeah,
Since from letter D.
Yeah.
You already said that 8 to 12 is greater.
Oh, H to 12?
No, 8 to 12.
8 to 12.
Oh. It's greater than what, 0?
0.
And
And
from
H of 6 is
H
the
of
absolute
6
max.
H of 6.
H of 6. H of 0
H of 0 must be the absolute minimum.
at H of 0. X equal to
X equals 0, careful, they're asking for where. Don't say H of 0. Long story short, critical numbers and endpoints. We have to test 0 and 6 and 12, and they just basically ruled out 6 because it's the relative max, absolute max, that's not good. H of 12, we already showed was greater than 0 by letter D, which means it's some positive number because of the overall accumulation positive area being greater than negative area. So long story short, at 0 is going to be the lowest value, so therefore it's going to be the absolute min.
You need to
How
state
come,
before.
how come the age of 12 is?
Greater than 0? Because
No,
remember,
I get that, but since that one has a smaller area volume, how come that one's not the answer?
oh, because there was a greater increase before a smaller decrease.
Okay,
So increase a lot, decrease a little.
okay.
So H of 0 is going to be lower, which is shown by the overall integral being greater than 0 from 0 to 12.
Do we need to state like the reason why those numbers are candidates?
No, because I stated the critical number endpoint candidates. You could say for absolute extrema
Okay.
if you want, or I was just saving time. For absolute extrema. Absolute min. Kiddos, we spent a lot of time on that example, but why?
very
The accumulator function shows up at least every other year. not every year.
Are we
So,
in?
did it come across her?
It looks this.
No, wasn't it? Did we have like
I
a,
remember a picture.
we had a graph where we had to find like the
There was a accumulator
areas
function?
underneath.
Well, like, we
these.
gave him
We
like
definitely practiced a lot in
three
class.
different.
There were like these
I
triangles,
just
and we
like
had to find the area of the
tables
triangles to find out where the
because
things
then it's
was.
easier to find the area.
We got like 3 different equations.
And I did it wrong.
So if we were to look at,
It's the one, it's the one with like a triangle and then like a rectangle.
It's the geometric shape.
It was like,
Yeah, I remember that.
Yeah, your hands down.
It was like,
I don't remember anything.
it was like number 5 or something.
They always. It was near the end,
Like 5.
Wait, were you talking about AB?
Remember that last year? It was a problem.
BC has 3 of the same as
It
AB.
looks like escargot.
Okay, wasn't like the entire BC test the same as AB except for like,
Not the entire, like half of it.
Don't we get 3 of their FAQs?
Yeah.
Yeah, let's go. Oh!
That one.
There's the graph of the derivative, which is similar in talking about the original because it's anti-derivative.
Yeah.
It was a different one.
I think it's the last one. Potatoes. True.
Where's this
That was that one.
which one was the easy one?
I did not. That one.
I realized what to do after.
Oh, but that's not an accumulator though. You're just playing with like a table and a function and a graph. That was an awesome FRQ, by the way. Whoever came up with that, that was super cool. This is the one that's more like the accumulator function, but it's written differently.
That one was rather.
Because guys, technically, they could have called this something like G, and they could have said that F is equal to the integral from, I don't know where they'd start, -2, I guess. -2 to x of g of t dt. They could have just changed this a little bit, but it would have been the exact same FRQ with the exact same answers, because when they give us an F prime, we were thinking about the original, it's like we're thinking about the antiderivative. Okay, all that to say. We finished 6.4, which we were supposed to finish yesterday. Go team. What's 6.5, just for you guys to see?
Isn't it kind of like Riemann sums, only with like one?
Trapezoidal rule, what's it all based on? A trapezoid.
Riemann sums, right?
And trap with.
And you can't have a Riemann sum trapezoidal without the trapezoid.
What's your base?
Yeah.
Delta x's, change in x's, right? And what are your heights going to be indicated by? Your f of x values depending, right? So, should the trapezoidal rule be super crazy? Let's go ahead and check it out. Let's check out the notes just real fast since we have a couple minutes left. We're comparing really quickly to left, right, and midpoint. The trapezoidal rule saying that when the intervals are equal, we could solve all the trapezoids separately, but what ends up happening if they're equally spaced? I didn't think you'd make a further part out of this last year, because usually on the AP they're not equally spaced. But does it make sense where this rule comes from?
Yeah.
If they're all equally spaced, couldn't we pull out the b minus a over n's, the delta x's, the bases? So we have 1/2 times b minus a over n, which combines to b. But how they get 1 of the left, 2 of all the middles, and 1 of the right? What happens when you go adding together all the heights after factoring out the rest? How many trapezoids will have the far left height? 1. How many trapezoids will share all of the in-betweens? 2. And at the very, very end, how many trapezoids will have the last? Just just 1. So then, we would have done an example on trapezoidal rule.
Simpson's rule.
What? Don't worry, it's not on the test. It's interesting though. And then we would talk about the error analysis. So guys, are we done? I don't think we are. Simpson's rule is not necessary for the test, which is a little bit nice. It talks about looking at trapezoidal rule a little further. I think we need Monday to do 6.5.